So my name is Justin Bechaver. I am a firearm and tool mark examiner. I'm a forensic scientist that specializes in firearms and tool marks. I'm also the manager of our firearms section. What is a forensic scientist? Well, a forensic scientist is basically any scientist that applies to scientific methods, principles, and testing of evidence to help answer questions, typically for court purposes. A lot of times we help a lot of law enforcement agencies, but we also help answer questions for a lot of lawyers and things like that, and judges and stuff. In general, the forensic testing that we do in our laboratory here is biology and DNA. They're typically the biggest section of our lab. They identify biological samples and determine sources of DNA. Then we also have blood stain pattern analysis, which is kind of a fun job because you get to play with blood a lot, and then you have to examine patterns and try and reproduce those and try to determine how those patterns got there. Another section is the chemistry or trace section, and they typically deal with identifying any kind of controlled substances, so any kind of drugs. They also do general unknowns like poisons and things like that. They also do trace, which is identification of hairs and fibers and paint, as well as fire debris for arson cases. Latent prints, a lot of times people talk about these as, the fingerprint section. Basically develop prints off of different items, do the comparisons to try to figure out who they belong to. And then I'll talk about firearms and tool marks here in a minute. And then crime scene response. Basically, we respond all over the state of Utah to try to figure out, to go and document crime scenes and collect the evidence that'll be later examined in the court or in the laboratory. So in the firearms section, mostly what we do is 90% of what we do is firearm related. So we check firearms for functionality, and then we do comparisons, which I'll explain here in a minute. But we also do tool marks. We also do serial number restoration, distance determination, trajectory analysis, and shooting scene reconstructions, which is probably my favorite. And then we also do NIBIN, which is the National Integrated Ballistics Information Network. So as part of being a firearms examiner, you have to know all of the nomenclature that goes with firearms. So for instance, these two photos here show you all of the different pieces and terms that relate to a firearm. Some of the easiest ones are the trigger safeties, magazine releases, things like that. But we need to know all of those different things. We also need to know the nomenclature that goes with ammunition. So each component of ammunition usually contains a bullet, propellant, casing, and a primer. When we get evidence into the laboratory, it's often necessary for us to actually shoot the firearms, and then we also we have to collect those fired bullets and fired cartridge cases. We do that through this really awesome water tank. Basically, it's just a big, almost like a jacuzzi without the bubbles. But we fire the bullets into the water. It slows them down and keeps them fairly pristine. And then we collect the cartridge cases in this little blue net over here. From there, we take our ammunition components and we go to a comparison microscope. So what it is basically I can look at two objects at one time. They're connected together via this optical bridge. So there's one set of oculars that I can look through. And when I do, basically what we're looking at in this case would be a fired bullet. So on the right here, you can see the rifling pattern from the firearm that fired it. And then we have our computer and our cameras to help capture images. If you look down the barrel of a gun, you'll see rifling. That rifling imparts twist on that bullet and it makes it more stable. It basically, if you think about throwing a football, if you want a nice tight spiral, the ball goes farther. But within those is these microscopic striations right through here. And when you have one bullet on the left-hand side and another bullet on the right-hand side, you can match up and look at those striations to see if they match up. And if they do all the way around the bullet, then a lot of times we can say that that came from a particular firearm. We can also do the same thing with cartridge cases. This is the breech face of a firearm, a Glock specifically. Right here you have your firing pin. The firing pin aperture is this rectangle part, and then this brass ring right here is where the cartridge head fits. So this translates to this part over here. This is your firing pin impression, your rectangular aperture, and then the brass portion of the cartridge case. And when we fire cartridge cases out of guns, due to the very high pressure that is exerted on the cartridge case, the breech face marks, which are these lines right here, they get imparted on the gun. And depending on how the gun is made, it leaves different breech face marks. We also do tool marks. So every time you guys use a knife to cut through a piece of cheese, take a look at that cheese with a little bit of a side light, and you'll see these microscopic striations that go along with it. Those all translate to the blade and the sharp edge on that blade as it's cutting through this, in this case, a rubber tubing. Again, we have our evidence on the right and our test marks on the left. So we'll make test marks with the tool, and then we'll compare those against our evidence. We can also do the same thing with diagonal cutters and copper wire. We can pretty much do this with any tool out there. Anything that's used to cut copper wires or anything like that. But basically, underneath the microscope, these are the microscopic striations that we're looking for from the sharpened edge of this cutter. We can also do what we call fracture matching. So in this particular case, there was a knife and a portion of that knife was broken off. A portion of it was found at the crime scene and another portion of it was found at a suspect's house. So I took those together and was able to show that they matched up together based on the way that it fractures. So this is a microscopic version of this area right here. And what you can see is the mirror image from the fracture. Serial number restorations. If you were to take and obliterate the serial number of a firearm, what we do is we can bring that back with various chemicals that etch the metal. What happens is when you stamp the firearm, when you stamp the serial number into a firearm, you compress the metallic grain structure underneath the numbers. And when you obliterate it to where you can't see it, we use various chemicals depending on the metal, and it'll etch the metal, the compressed metal versus uncompressed metal. It etches them at different rates and the numbers come back. So we can do this on firearms, which is primarily what we do. We've also done them on bicycles. We've done them on airplanes, on trailers, trucks, all kinds of things. Distance determinations. Every time you fire a gun, not only is the bullet expelled, but also hot gases and unburnt and partially burnt gunpowder. And so what that stuff gets captured onto clothing and to skin and that sort of thing. And so what we do is we'll estimate the muzzle to target distance by setting up a series of witness panels, and we make shots at different distances, typically 3 inches, 6 inches, 9 inches, etc. And we observe the spread of that pattern and try to estimate the range in which the firearm was from the target. Then we also do shooting reconstructions, basically trajectory analysis. So we'll go out to a crime scene and we'll document all of the trajectories from all the bullet holes. And then we have all these fancy lasers and things like that that we can use to help try to recreate the scene. The reason I like this so much is because this is the one aspect that you really get to do a lot of empirical testing. So we've done all kinds of things like shooting all kinds of ballistic dummies and ballistics gel, shooting glass, shooting cars, actually. So there's a lot of fun things that we get to do with this types of reconstructions. And then the last thing I'll talk about is our NIBIN program. NIBIN is the National Integrated Ballistics Information Network. And essentially what we do is we put in recovered cartridge cases from crime scenes, and we make test fires with guns, and we put them into this really big database that gives us this really super cool 3D image. And we basically do a comparison like we would on a microscope. But what it does is it helps us by using algorithms and computers and things like that. It helps us link shootings across the state and actually across the country more quickly. And so we put the cartridge cases in, it takes an image, and then it gives us back a list of possible guns or other cases that are linked to it. And then we go through and try to see how well they match up. And then if they do, we issue out a hit. I know this is like a really quick and dirty explanation of what I do, but I would love to take questions if you have any.
Can you talk a little bit about like what I guess your job requires? Like, did you have to get a degree or just some training? What all do you have to do to get to where you are?
So I have a bachelor's degree in biochemistry from Eastern Oregon University. In order to work in our laboratory, you do have to have a bachelor's of science degree in some type of a hard science. So typically biology, chemistry, biochemistry, one of those types of things. Depending on what type of forensic analysis work you want to do, if you want to do crime scenes, a lot of times you can go to criminal justice degrees. A lot of those will be qualified for that. But if you want to work in the laboratory, you really need to get that hard science degree. It's got all the classes that you need and the lab experience that goes along with it. I would honestly recommend going that route simply because your options after you graduate from school are so much better. If you focus on just like a criminalistics degree, you're pretty much set in that field. But if you get just a general biology, chemistry, biochemistry type of degree, while you're waiting to work in a forensic lab, you can also work in other labs, any scientific lab. And all of that experience will help get your foot in the door as well.
We do have one in the chat for you. It says, do you know much about what it takes to be a detective or investigator?
So that's not necessarily what we do, but I can kind of speak anecdotally to that. I do deal a lot with a lot of detectives. We talk a lot about different cases and things like that. A really good buddy of mine is a detective for one of our local agencies, and the route he took was basically he went and worked in the jail for a while as a correctional officer, and then he became a patrol officer. And then through all of his training and experience of being a patrol officer, he was then able to move up to being a detective. There's a lot of, kind of on-the-job training and a lot of specific training classes that you need to take for those, and most of those are offered through various law enforcement agencies.
What other questions do you guys have before we go back to the main room?
So I was actually wondering how often you use physics in your day-to-day life.
Well, we don't use a ton of it every day, but when we do shooting reconstructions and things like that, there's a lot of physics that goes into it when we have to calculate the aerodynamics of a bullet and the drop of a bullet over a longer distance. Let's say if we had a shot that was fired from 800 to 1500 yards, the physics will come into play on that as to how that bullet flies through the air. So there are aspects of it that we do use.
See if we can get this one in really quick. Someone asked, would you say that forensic science is a good line of work?
I really enjoy it. It's one of those jobs that if you are you care more about the science and explaining things to people, you do really well with it. If the side of, if you kind of wear your heart on your sleeve a little bit, and a lot of times when we have like crime scenes and things like that, there's a lot of sad things that can happen. And so if you're one of those that can kind of separate yourself from those emotions, then I think it's a great and very fulfilling field.